Okay, part 2. So far, the important part about this is if A equals the height of the triangle, there's one solution, and it is a right triangle. And if A is less than the height, there's no solution because that side A swings around and never will meet the other side. If A is greater than or equal to B, there's one solution. And if A is in between the height and B, there are two solutions. So which one is this? So here's where the rubber meets the road. We have a capital A of 47, side A of 70, side B of 62. So let's look what that shows up. So I kind of sketch it here, 47-degree angle about, and I'm going to call this distance 62, and that is that's side B across from angle B. Notice I put B in parentheses because I don't know exactly where B is. Alright. So I don't know exactly where B is, so I'm going to just put parentheses. B might stop, angle B might be down here, it might stop down here, up here, way over here. So B is somewhere, because I haven't told little c, so I don't know how long this side is. But I do know how long side A is. Across from here, it's 70. So I cut a piece of string, and it's more than 62. So I'm going to call that 70. And I don't know what angle it is, because at point C, I don't have an angle. So it could swing, we're not sure where it is going to swing to. So, but how many triangles are possible? Remember, I can extend this side any length because it's unknown. I have to keep this the same and this the same because they are known. But this, I know its length, so this is supposed to be 70. So, but I don't know what angle, so it can swing all around. But how many different places will it meet AB and make a triangle? Well, back here it's too long to meet AB, and here it's too long to meet AB. But if I go way down here, I can have it meet AB by extending it. Remember I said I didn't know where B was, so now I have an idea where it is. So this is side, this green thing is side A, it's 70 long. It must meet, it must make an angle B right here, down here. So there's only one solution. Let's see if the picture makes sense with the math, because we had a test for that. And our test was to drop a perpendicular, call it H, and do the test. So I'm going to say sine of 47 equals H over, that's opposite over hypotenuse. So remember this H is for height, not hypotenuse. The hypotenuse in this problem is over here. So what is 62 sine 47? 62 sine 47. Let's find out what that is. I need to get my calculator out. (62 sine 47). 62 sine 47. And let's see what mode I'm in. Always the wrong one. Alright, I never remember changing it, but I'm always in the wrong one. Some rule of physics. 62 sine 47 is 45. So that tells me that the height is 45. So how, if the height is 45, what's the relationship between A, height, and B? You can see that A is greater than B, and they're both greater than the height. So back up here, we find out when A is greater than B, we have one solution. So from there, we can set up the sine relationship, such as 70 over sine of 47 equals 62 over equals 62 over sine of the unknown angle B. So whenever you have that, you know your last step is going to be an inverse sine step. So let's just multiply both sides by sine of B. Sine of B will disappear from here and pop over here. And at the same time, I'll multiply both sides by sine of 47. It'll disappear from here and pop over here. So that will give me sine B times 70 equals 62 sine 47. And that's what some of us call cross multiplying. So if you think of it in that way, it's this times this, sine B times 70 equals this times this. All right, so we end up solving for sine B by dividing this by 70, and when I did that, I got 0.648. And what angle has a sine of 0.648? Well, the inverse sine will tell you 0.648 equals 40.39 degrees. Well, we can get, that's this one right here. So let me draw that in and write it in, 40.4, we'll say, degrees. And then we can find angle C by subtracting the sum of these two from 180. And then we can use the sine relationship again to find side C, but you have been well taught in that, and if you do it, you will see, first of all, you'll get that extra angle C to be 92.6 or a little near that, and side C, if you use the sine law of sines again, side C turns out to be 95.6, so check and see if it does for you. All right, so I'm not going to go over it step by step as we've done several of those together. All right, we'll do one more, and notice the relationship here is in the very beginning we knew one angle and two sides. So there's the bad word if you read it backwards. So that's the one that we always have to check because it might have one, none, or two solutions. All right, let's try one more. I'd like to keep these visible, so maybe I can just cover them. All right, so my example solutions, there's my solutions, and my example that I want to know which one of these are we going to have with this problem. So we have A equals 39 degrees, and we have side A equals 50 and side B equals 61. So first give yourself a sketch of it, and we'll see which of the scenarios we have. Right away I can see it's the bad one. It's two sides and an angle. So right away I know I could have problems. So that which is not to be named comes up again. So let's go ahead and draw it. I have a 39, so if this is 45, maybe 39 is like that. 39, and that's A, and side A is going to come out here at some angle. I don't know what. I'll get my string to help me with that. And B is 61. So let me draw this bigger so I can show you with the string as well as with math, because we're not going to have a string to twirl around. So A is going to come out of here and be 50. So let me get my string. Where'd it go? Where'd it go? Where'd it go? I don't know if the same one will work, because if this is 61, B is 61, I need a shorter one for 50. So if this is about 61, I got to cut this so to make it 50. All right. Either my string is very tough or my scissors are very weak. I think I have a combo going here. Okay. Jeepers. I need like a chainsaw. Why can't I just get a piece of string that you can cut? All right. I don't know what else to do with it. Oh well, that's the best I can do. So I've cut the string so that it is now 50, and it's going to spin around here. And when I do that, of course my push pin is gone as well. Of course. So go get another push pin. Coming right back. Alright, so I'm going to put the push pin in here, and I'm going to spin it to show you. Again, this side, I'm not sure how long it is, so it could be very short or very long, or somewhere in between. But can you notice, if this length is 50, then could I not make a triangle over here, or not here, but couldn't I make one over here? So couldn't I make one here, which is side, this would be 50 here, or couldn't I swing it over here and make a 50 here? So this is a very troublesome one because I have two possibilities. So let me move my, so this could come off of here. It's supposed to meet at the vertex. So let me scooch it over here. So I have 50 here if I swung it that way, or 50 here. So the other one didn't work that way because this was too long, and so when I swung it over here it didn't meet any of these sides. So this one does. So let's check that out with math to see. So we're getting two solutions. So we're going to drop the hypotenuse. Let's move this now that you've seen it's a possibility. Let's move this, find out what height is. So we're using this angle. We have sine of 39 equals h over 61. And when I do that, sine 39 times 61 Alright, I keep typing it in wrong. Alright, I get 38.4 for H. 38.4. So, if the height is 38.4, what's the relationship between A, H, and B? Well, we can see that H is smaller than A, and A is smaller than B. So we go back up to that scenario. You can see that we were expecting two solutions. So this is how we handle it when there are two solutions. All right. So when we have two solutions, I'll pick, remember I showed you with the green string, one of them was here and one of them was here. Let me shut down this video and set up those two solutions on part 3. See you in a sec.